Hi everyone. In today's challenge, we are going to solve this problem. The problem name is Find Eventual Safe States and the problem number is 802. Alright guys, so as usual, first of all, we are going to clearly understand this problem statement. After understanding the problem statement, we will move to the logic part. We will see how we can solve this problem, what is the logic to solve this problem. And after understanding the logic, we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java and JavaScript programming language. Fine guys, now let's see what this problem says, right? So let me move all these things and let's understand the problem statement first of all. So problem says there is a directed graph of n nodes with each node level from 0 to n minus 1. So first thing we need to notice is it is a directed graph, right? It is not undirected, it is directed graph. If there is edge exists, then you can move from A to B, right? It's not like you can also move from B to A. Okay, second thing is nothing but the node starting from 0 till n minus 1, right? And the graph is represented by a 0 indexes 2D integer array graph where graph of I is the integer array of node adjacent to the node I. So simple guys, there is nothing. Let's say we have given us some graph, this is a graph array which is given to us, right? And in this graph array, let's say graph of I is nothing but 2 4 6, right? And I, let's say graph of 0, right? So what it says that this 0 is nothing but I. So this says that from I, what are the node adjacent to this I? This I, the node adjacent to this particular I or 0 is 2, 4 and 6. That means there is a node exists from 0 to 2, 0 to 4 and 0 to 6. Nothing else, right? It make it easy, right? Just simple nothing but we are given graph of one array, we can say we are given one array. The name of an array is graph, and inside each index we will have also one array where all the values which is present in that nested array is the adjacent node of that particular index. Next guys, it says a graph is a node. A node is a terminal node if there are no outgoing edges. So what are the terminal nodes? In the example, in this particular image also you can see the node are nothing but this is a terminal node. There is no node exist, right? We can't move from this node to anywhere. You can see guys, right? And this 5 also terminal node because we can't move anywhere, right? From this particular node. So these are nothing but called a terminal node. And if there are no outgoing, not this line. If a node is a safe node, a node is called a safe node if every possible path from starting from that node leads to a terminal node. So now we are given two terms. First is terminal, we have seen already. Now second is safe node. Safe node is nothing but a node. If we are at that node, then no matter where we can move, we always gonna reach to the terminal node, right? So we'll see this how we can find that particular thing. But I hope you are getting the meaning of we can say the safe node. Safe node is a node if we are standing any safe node, and that node leads to terminal node. If we choose any path, let's say this is safe node, and if there are three path exits, so no matter which path I take, but all the paths led to a terminal node, then this node is called nothing but a safe node. I hope it makes sense, right? So one more thing you can see from this also, a terminal node is also called a safe node, right? Fine. Return an array containing all the safe node of a graph. The answer should be sorted in ascending order. Now, what we have to return? We have to return all the safe node. Means from where, if we take any path, we always lead to a terminal node, and the answer should be in ascending order. That means if there are this node exit 2, 4, 6, 0, then we have to write first 0, then 2, then 4, then 6. Means it should be in sorted order, right? Fine, we have seen the problem statement. Now let's see the examples so that you can have better understanding. So guys, in this example, you will see that we are given something like this array, graph array, right? And inside array, I have told you that on each index we will have also one array, which tells us that these are the adjacent node of this particular index. So on 0 index, we have 1 and 2 adjacent node. For one index, we have 2 and 3 adjacent node. So, this will keep going, right? Fine. Now guys, you can see what are the terminal nodes, which does not lead to where we cannot move any particular node, right? There is no adjacent node present to that. So you can see 5 and 6, not adjacent, it's wrong to say adjacent, but there is no path starting from that particular node, right? So you can see there is a 6, there is no path existing, there is 5, also no path existing. So we can say 5 and 6 are nothing but a terminal node, right? Fine. And what are the safe node? Now let's find a safe node. So if you will notice guys, 5 and 6 always going to be safe node as well, right? The nodes which are terminal, they are also going to be a safe node because that are the only endpoint, right, where we want to reach. Fine. Now if you will see from 0, if we focus on 0, so you can see with 0 we can move to 1. From 1 we can move to 2, right? But we from 1 we can also move to 3, right? And if we move to 3, if we come to again 0, so we can say guys this path from 0, if we take 1 and from 1 we go to 3, so this is not reaching me to this is not allowing me to reach to terminal node, right? So that means we can say 0 is not a safe node, right? It's not a safe node. But if you will see 1, fine, let's move to the 1. 1 is also leading to 3, and 3 come back to 0, and 0 come back to 1. So there is one path exists which is not leading him to reach to the terminal 1, right? So we can say 0 and 1 are not safe now, right? Let's see now third one. So is third not third, let's see first of all second. So is second is it we can say safe node. From second we can go to, you can see we can go to 5. We can directly go to 5, right? From second we can directly go to 5, and from 5 we cannot move to anywhere. So that means nothing but second is a safe node, because there is only one path exit, and that also led to a terminal 1, right? Cool. And let's move to now 3. From 3 we can go to 1. From 1 3, from 3 we can go to 0, 0 we can go to 1, 1 we can go to 3. That means this is also not leading to terminal 1, right? So it's keep moving me in a circular loop. So we can say this is also not a safe node. Now let's go to 4. So from 4 we have only one path which is leading to a terminal 1. So we can say nothing but 4 is also safe. And 5 and 6 always going to be safe node because they are terminal 1, right? So we can say guys 2 and 4 is nothing but the safe node with this 5 and 6. So answer is going to be nothing but 2, 4, 5 and 6 because it is in sorted order. And you can see also output is nothing but 2, 4, 5, 6. 0, 1, 3 is not a safe node because they are not allowing us to reach to the terminal 1. There is at least one path exit which keeping me in a loop. Does that make sense, right? Fine. Now guys, let's see the second example. Second example is nothing but a graph example. So I will suggest you to try by yourself. Try a graph like 0. You can move to 1, you can move to 2, you can move to 3, you can move to 4. Then from 1, just try to make a graph and try to find your answer and then match with this output. If you are getting this one, that means you have clearly understood the problem statement, right? Fine. Now guys, let's see the logic part and see how we can solve this problem. So what I'm going to do, I'm going to remove all these things, and logic is going to be really again easy. We don't need to do anything else in this problem, right? Just one algorithm and that will solve our problem, right? So what is the logic going to be here? So guys, one thing is we notice here, the only way we can say that this node is not a safe node when it keep me allowing in a loop, right? If it keep me pushing in a loop, right? We can't come out from a loop. So if any loop exits from 0 node, that means it is not a safe node. Simple. One line answer. If any node, if I'm starting from 0 and if any path is allowing me in a circular loop, right? If any loop is exist from there, so you can see this loop is there, right? So this will coming again and again. So if we found any circular loop on this node, then this node is a safe, not a safe node. But if there is no loop exit, then that is a safe node, right? If you will focus on second, so this is nothing but a safe node. This is also safe node because there is no loop, right? But if you will focus on one as well, so you can see from one we can go to, we can say 3, from 3 to we can go to 0, 0 we can go to 1. So simple thing, we have to check whether that node is a loop, is creating a loop or not, right? So if it is the case, then we are saying that it is not a safe node, otherwise it is a safe node. Now how we can do this all? So guys, nothing but we are going to do, we are going to say we are going to use a define, or we can say dfs, depth first search, and here in this function just we are going to keep passing our node, and we are going to check if that node is creating a loop. We are going to check for each node, right? If node is creating a loop, that don't take it, it is not a safe node. If it is a node creating a loop, then it is a safe node, so we are going to take it, right? Simple thing. And how we can do this, we are going to see in the code part, but here just give you a little brief idea. So here we can say if a node, first of all, it should not be in wisdom, is we are not taking it, that thing we will discuss on the code part. But if node is already been occur, right? If it is already occur and that node was not a safe node, let me show you here. Here you can see guys, we have already seen that 0 was not a safe node, right? And then we were trying to find out the 1 whether it is a safe node or not, right? So what we did, we from 1 we went to 3 using a dfs. From 3 we can go to 1, 0, right? Now we don't want to move again because we know 0 is not a safe node, so we'll say if it is a safe node then only move to ahead, otherwise don't move ahead. I know it's hard to understand, but let's say you have understood 0. Let me try run for this guys, so because it's not like easy one, so you have to understood this. So let's try run here. So we are here at 0, right? Initially we are going to check for 0, so we'll say okay fine with 0, let me draw all the index 0, 1, 2, 3, 4, 5 and 6, right? Now what I'm going to say 0, for 0 you have to go 1, right? I move to 1, right? Fine. From 1 I have to move to 3. I have to we can say traverse all the paths. So from 3 we are coming back to 0. I hope you are getting this, right? From 3 we are coming back to 0. So will this cause we can say this particular thing cause a safe we can say terminal node? No. this particular thing is creating a loop, so it will not help us to lead a terminal node. So we can say this is not a safe node. But how we are going to check in the code part? Simple thing, guys. What we are going to do, we are going to say fine. First of all, move to all the paths, and you come to here 0 1, and from 1 you are checking whether it's in. We have already traversed it. No, if we haven't traversed, then keep traversing. Okay, fine. We move to this, and we can say okay, we are got 3 now. Did we traverse this earlier? No. Then move ahead all the paths of this. We come to 0. Did we traverse it? Yeah, we have already traversed this one. So we have already traversed this. Then what we are going to do? We are going to say fine, just return a false. 0 we're going to have false. But only when 0 was not already been got a safe node, right? If it is already a safe node and we were trying to from 1, then it will gonna give a true, right? I'll tell you why, but for this particular thing, let's keep it fast because this is the first time, and because we haven't all the default value was nothing but false only, right? 0 false, 1 false, second false, all the values initially are false, so we can say 0 having a value false. Now we come to 1. So we can say for 1, we can say it is initially false, right? We are going to make it false because this it is not a safe node. Currently, we are assuming we'll move to the all the nodes. From 1, we can move to 2, fine. From 2, we can move to fine. So this one is going to give a true. But we'll move to all the nodes, right? So then we will move to 3, and 3 from we will move to 0, and can say that 0 has been already traversed and the value was nothing but false. So we are going to say fine. This value is also going to be nothing but false now. So 1 is also false, and we'll keep doing all these things, and we'll say if a node is coming again, then check whether what is the value of that particular node. If it is true, then take it true, otherwise take it false. Simple. I hope it makes sense. Now let's move to the implementation part and let's see how we can implement this one, right? So I'm gonna first of all with the Python. So first of all, what I'm gonna do, I'm gonna say let's find out first of all length of our nodes. How many nodes are there? So we can say graph. So we can say directly length of graph. And after that, once we found a length, we are gonna say cool. Just create two things. One is safe node. So this safe is gonna be initially false for all. We can say length I am giving n, and is visited. Means did we have visited already? So it is also gonna be false. Right. So once this is done, what we are going to do, we are going to say that okay, just define one function solve, or we can say DFS, and here we are going to take a node, and we are going to say initially here we are defining is listed of node is going to be, I'm going to make it true, and we are going to say safe of this node is going to be nothing but we can say fast. Initially I'm defining a fast because if in future I come in a loop, that if same node occur, then this value should take a fast, right? Fine. And here we can say fine. So here I'm going to say for child in this particular adjacent list of nodes. So adjacent list is nothing but a graph of node, and we're going to say if this child is already in visited, if is visited, if this child is false, right? If node is visited, the child we can do like this as well. This is also going to tell whether it is false or true. If we have already traversed this one, right, then we don't need to traverse. But if we haven't traversed, then we need to traverse, right? If we haven't traversed, this will condition will true, and we can say traverse for this child. And we can say if this child also returning, if this function is also returning a false, then we can say return directly false, right? Otherwise you don't have to return, you have to keep moving for the next child as well, right? Else we are going to check if this means this node has already been traversed, so return that particular value. So we can say if our this safe of this particular child is true, then keep moving for next child as well. But if it is false, so if not safe of child, so we can say if it is false, then directly return here false as well. No need to move to the next child, right? And we'll come out from this loop and we'll say safe of node is now going to be true, because we have seen that all the nodes were true, right? All the paths which are exist to this node is nothing but having a leading us to terminal node, so we can say directly return true, return true. Fine. Now we can say fine, this is the case. Now we are going to say for I in range of n, just run this loop, DFS function for all the nodes. But if that node is already node visited, if it's visited of that particular I is false, if not that, then only you have to run this function DFS of this I. And after that, just what you have to return? You have to return a list. We can say value, or we can say value of I, not value. We can directly say index, right? Index for I in range of n, right? And here we can say if our value, if our what we can do, we can say if safe of I exists, right? Now let's run this code and see whether something fine or not. So we got a one runtime error that is nothing but on this condition only, unexpected as if expression. So it need to write if else statement. So what we can do, we can say fine, we can write here if condition here if safe of I, right? If we are writing over there, then we need to use else condition as well, right? So you can see guys, both the test case passed. So let's try to submit this code as well. And this will definitely gonna submit, right? It is a medium level problem, not a hard one. So you guys can see that it successfully got submitted. Now let's move to the next programming language, which is nothing but C++. And here we are going to say find. First of all, let's find a length, which is nothing but graph.size. Then we are going to find two. We can say vector. The data type is going to be boolean. And here we can say find the name I'm going to give is nothing but first save n size default value false. Then same thing vector bool and is visited n size false. Fine. Once this is done, we are going to say fine. Now what we are going to do, we are going to say call this call one function that is dfs for all the nodes, right? But only when that node is not visited. So if node is visited, of this particular I, then only you have to call that dfs of I with this particular save node and is visited node and this graph, right? I'll define this function, but let me first complete this particular function. So once we have done all the traversals, now we are going to check for int I is equal to 0, I less than n I plus plus. If safe of I is if this node is true, then only appending our result. So we can say vector of int and here we can give a name result, and we can say result dot pushback this particular I, right? If it is a safe node, and after that we will return this result. Now let's define that dfs function over here. So we can say nothing but bool dfs, and it is going to take a node, then it's going to take a vector of bool. First of all, it's going to take a save, then vector of bool, then it's going to take nothing but we can say is visited, right? And at the end, we're also going to take our graph as well, because we are defining it outside of this function. We are not using a nested function here. Fine. Fine. Now as this is done, we are going to say save of this node initially make it false, and is visited make it true. We have already visited now. Fine. Now we are going to say, let me write true here. Fine. Now we are going to say for child. We are going to move to all the child for child. And in this, we can say graph of this particular node, you have to move to all the child, and that child, if it is not visited, then what we are going to do, we are going to say find. If it is not visited, then you have to say not node child. Then you have to visit it. So for visiting, we are going to call this function again for this child, the save, the is visited, and we can say graph, right? And if that value is returning us true, then fine. Then we will move to for next path, next child as well. But if it is giving a false, then we don't need to move to the next child. We can directly return false here, right? If any of the path fails, then we are directly returning a false. If it's not true, then return directly false. And if it is not, if it is already visited, then check if save value of this we can say child is true or not. Say value of child is true or not. If it is true, then we can say directly move to the next child. But if it is false, then directly return false. And outside of this while loop, for loop, we are going to say save of this node now make it true, because all the paths are true, and return nothing but true as well. Fine. Now let's run this code and see whether it's working fine or no. So I hope it should work, right? You can see both the test case pass. So let's try to submit this code as well. All right. So it's taking a time. Yeah, finally it got submitted, right? So now let's move to the next programming language, which is nothing but we can say Java. Let's quickly define here as well. First of all, length int n is nothing but a graph of length, and we can say let's create a boolean array, and the name I'm going to give is safe is equal to new boolean. Let me write boolean, and size is going to be n. That same thing boolean, we can give a name is visited, new boolean, size is going to be n. Fine. Now what we are going to do, we are going to say fine, it is the case. Then let's go to all the nodes and check if that node is already visited. Then we can say fine, you don't have to call this dfs function. But if it is not visited, then call this dfs function with I, and we have to pass the save, then pass is visited, then we have to pass this graph. Fine. And after this thing, we are going to say for int I is equal to 0, I less than n and I plus plus. We are going to check if this save of this I is true, then you have to put in your result. So you can say result dot add this particular I, and we haven't defined result, so we can say list of integer, and result is going to be nothing but new array list. Fine. And at the end we are going to return nothing but this result. And now let's define that dfs function. So we are going to say boolean dfs, and here we are going to take node. Let me write node, and then we are going to take a boolean array, and that boolean array, let me just see this boolean array, and the name I'm going to give safe, and then boolean array, then we are going to give a name is visited, then one more thing int graph. Fine, now once this is done, we are going to say, first of all, say safe of this node is going to be nothing but we can say false initially. Once this is done, we are going to say is visited also of this node is going to be nothing but true. We have visited this particular node, right? Now once this is done, we are going to say move to all the child, so we can say for moving all the child, we can say on child of this graph of this particular node, and we are going to say find if is visited this particular node, not node, we can say child. If it is false, that means we have to visit it, so we can say dfs of this I, node I, we can say child, and then safe, then is visited, then we can say graph, right? And we can say here if that particular function is returning a false, then no need to traverse for next child, just return directly here false. But if it is not visited, so if it is already visited, then we can say find check is safe value. If safe of this node means it is not a safe node, then return false directly here. Fine. Now what we are going to do, we are going to say fine. Now here we are going to say out of this for loop, we are going to say return true. But before that, let's mark the safe of node is going to be also true. Fine. Now this is done. Let's run this code and see whether it's working fine or not. Okay. So we got a compiler error is visited. So the spelling is mistake here. Now let's see. I hope it should work, right? So one first test case is passed. Here it's getting a 4 right? But output is nothing but 5. So did we have something wrong here? All right, so let's check this one as well. It's an interesting one. Boolean of Helm is visited. We are moving all the visitors. We are passing safe and visited, and then we are saying that if it is true, right? Safe file is true, then add in our result, right? Fine. We are making it false. We can making it true at the end. We are making it true. So for child in the graph node of this, so right. So here's the mistake. Safe of child, right? Now let's run this code. Actually, we are checking for the main node every time. No, we don't need to check. We need to check for the child node, right? So you can see, guys, all the rest case passed. So let's try to submit this code. Finally, it should submit as well, right? So you can see, guys, it successfully got submitted with Java. Now, last programming language JavaScript. I know the video is going to be very long now, so let's quickly complete this one as well. So let any element graph dot size, we can say length, and after that we are going to say for in what we are going to do now. We are going to create a two array, right? So we can say const our array, our node array. We can say save is going to be nothing but is going to be new array of how much size and size. Same thing. What this const is visited is going to make a new array of how much size and let me just say this. Fine. Now we are going to say for let I is equal to 0, I less than n, I plus plus. I'm just going to say safe of this I is going to be nothing but false, and is visited of I of this I is going to be nothing but also false. Fine. Now once this is done, we are going to say fine. Now let's define one function. Or before that, just let complete all these things except the function. So we are going to say for let I 0, I less than n, I plus 1. We are going to call for each node a function that is name is dfs. So if only if is visited this I is false, right? Means we haven't visited this earlier, then only you have to call this function for this particular I. Fine. Now once this is done, we are going to say after that we are going to say for let I is equal to 0, I less than n, I plus plus. If that node is we can say if safe of I is true, right? If that node is true, then only we have to add in our result. Safe of I is true, then only we are going to add in our result, and our result is going to be nothing but we can say like this, right? So we can say if it is true, then result dot push. We have to push this particular I, and we have to return this particular result. I hope this makes sense, right? Fine. Now once this is done, what we are going to do, we are going to say let's define that function which we are calling here dfs of I. So we can say const dfs. Let's make write a const dfs. It's going to be nothing but take a one argument only, that is node. And why it is so? Because the two argument which in three arguments safe is visited and graph is already going to come from this function as well, right? We are defining a nested function here. Fine. And we are going to say safe of this node is going to be nothing but always false initially. Fine. And after that we are going to say for first of all let market is visited as well. Is visited of this particular node is going to be also true. Fine. Now we are going to move to all the childs for let I is equal to 0, I less than graph of this particular node dot length, right, and I plus plus. And here we can select child is going to be nothing but graph of this node of 5. But now if we are going to check if this child is visited of this child, then what we can say if this child is not visited earlier, so we have to visit it. So we can say dfs of this child, and if this df function is returning false, then we don't need to move for next child as well, right? We can directly return false. But if it is not visited earlier, so we have to check. Let me just use curly braces. If it is not, we can say if it is already visited and the safe of this child means if this child is not a safe node, then return directly false. After this for loop, we are going to say find. Just say safe of this. Let me write a safe of this node is going to be nothing but true, and we are going to return nothing but here true. Let me write right. Now let's run this code and see whether it's working fine or not. And I hope guys it should also work, right? You can see both the test case pass, so I try to submit this code as well, and it's definitely gonna submit. So you guys can see that it successfully got submitted. So guys, I hope and I believe guys you have successfully also submitted in your, we can say, local software as well. So guys, I believe that you have understood the problem statement part, logic part, and the implementation part. If you have any kind of doubt in any of these three sections, you can add in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.